Good morning, friends. In the previous video, we saw the solution of pulling data from nextbus.com through Apache NiFi and then on pushing it onto the Elasticsearch. People who haven't watched it, I suggest you please do. I've shared the link in the description. In this video, we'll see how to implement the data pipeline. We have two use cases. One is extracting route information and the other one is extracting bus locations. Let's start with the routes first. This is the user interface of Apache NiFi. Let's start with creating a process group called route stops. Get inside it. And the first thing to do is invoke the HTTP. Invoke HTTP. Let's now take a look at the web service which Nextbus provides. This is the web service for extracting route information for a particular agency, and route is 1. And if you see the response, we have body as route element, and at level 1 there is route information, and level 2 has various stops in it detailing the lat long location of it. Now let's get back to the processor. Copy this URL, invoke route stop HTTP. In the properties section, give the method as get, and URL is this, and rest it's all default. Just click on apply. The next step is to extract XML information. Let's create a processor called split XML first and define its properties and keep the depth as 1 because the route information is at level 1. Now let's create the connection between these two. On response, I want to split the XML, and rest of the relations I can keep as automatically terminate. Notice this is runnable now. Now that we have split the XML, let's extract the XPath information, which is, let's set the auto terminate to in case of failure and unmatched. On the property side, we want to extract the flow file attributes and route tag. For now, I'll just keep on keying these properties. I'll explain once it's done. So in here, what we are saying is from the root element, we want to extract the tag attribute and set it to root tag. And likewise, the title will be assigned to root title. Click apply. and set the connection. Oops. Yeah, in case of split. Failure and original leaking. Let's test the pipeline by logging a message of the incoming attributes. Right, on successful match, I want to log a message, and this we can terminate. Right, so now let's start the pipeline. You see there is one message which is pulled, two. Now let's stop it and take a look at the data. So the attributes are root tag and root title is what we are interested in so far. On the content side, we have this XML, which is pulled from the web service. Close it. So looks like so far so good. Let's close this. The next step is to extract stop information. Let's copy this and paste it. Since the stop information is at next level, we'll keep the depth as 1. Click apply and extract stop information. So we'll just repeat the same. Here we'll get rid of these two, and what we want is the ID of the stop, which is located at stop ID attribute, and let long tag title. Right, these 5 properties we are interested in. Let's click apply and start connecting these processors. Unmatched, I want to do this, but the rest of them I can terminate. Unsuccessful split, I want to evaluate, and let's just use the existing log message. So far we have root and stop information, plus there are some unwanted attributes which we can get rid of by introducing a new processor called root on attribute for validation. Let's call it as is root stop, and the validation would be this, wherein I'm expecting all of these attributes to be present. Only then I'll proceed. in case of matched, and then log a message. Is root stop. Yes. Let's get rid of this connection and terminate the unmatched ones. Let's now run it. Stop this for now. Yep. So there are around 188 stops, which we can take a look. List queue. So attributes we are interested in are ID, lat, long, route information, tag information, title. So it looks like we are good. The next step is to create an attribute called geolocation. Let's have a processor called update attribute geolocation. Geolocation and use this expression to concatenate lat and long and make sure it is comma separated. So on is root stop, and the next step is to put all of these attributes into a JSON document. I want these attributes like ID, lat, long, tag, title, and then there is an expression which is this. And the destination is gonna be flow file content because we want the JSON file, not the attribute. So click apply. Success. And then push the document to Elasticsearch. For that, we'll create another processor called put Elasticsearch. Yep. Now provide the Elasticsearch URL. I've already put them in a parameters group. Scroll down and let's define the identifier attribute as ID. Click OK. The index is gonna be root stop index underscore doc. So this index is what will be created in Elasticsearch, and the identifier will be ID for each document, and the type is underscore doc for now. Let's click apply. Success. Let's create another log message. Successful one. And let's also resolve these issues by auto terminating the failure ones, and in this case failure and retry. So by now we are ready to push it to Elasticsearch. Let's take a look at Elasticsearch. There's nothing as of now. Let's run this. Okay, I think we're good. So all of these should be in Elasticsearch now. Yeah. So there is an index with this name is created. Click next. Create the index pattern. Right. Now if you go to discover, you should see these documents. Let's take a look at it. I have the identifier, lat long, root information, root title, tag, and stop title. So looks like all the information we were looking for is already there in Elasticsearch. Now that we are done with routes, let's create a pipeline for bus locations. Let's go back, route stops, and create another process group for bus locations. So we have seen in detail how to create the pipeline for routes. Accordingly, I'll create the same for bus locations. I'll not be creating them individually. I'll do it once and then take you through each one of them. All right. Now that we have the flow in place, let's go through it one by one. The first step is to invoke bus locations web service. Let's see the web service. The URL command is vehicle locations for a agency and on route 1. And let's get back and go through the flow. Once we get the successful response from HTTP, we split the XML and extract vehicle information. These are the values that we are interested in. The lat, long, ID, route tag, where is it heading, so on and so forth. Uh, In the next processor, we are validating. We are only interested in vehicle location document. So this is where we are checking the vehicle ID, and if it is present, only then proceed. In the next processor, we are updating the geolocation information, which is nothing but lat long concatenated by a comma. And in here, accumulate all the attributes and create a JSON document out of it. And this is just push it to the Elasticsearch. Now let's run this whole pipeline and see what happens in the Elasticsearch. Go to stack management, index patterns, let's see, create. A vehicle location index is already pushed from Apache NiFi. We'll create the index and go back to discover. Switch to vehicle location. We see couple of records. Now let's go to Maps and create one for us. Add a layer from Documents. The index is roots of first. Add a layer and provide these details. The name is root number 1 stops. Opacity is 55. Tooltips I don't want to give. Sorting no need. Scaling no need. Filtering yes. The root is 1. So let's select 1. And the marker is fine. The size I'll go with 4. That's it. Save and click on it. Fit to data. It will take you to the root. Now let's add another layer for bus location. Add layer. Again, tooltip I don't want. Sorting, scaling, filtering, yes. Root tag 1. And in this case, let's have an icon called bus. And yeah, I'll go with this color. And size, let's make it 9 seems fine. And here's the interesting bit. We can label each icon with vehicle ID, for example. So let's reduce the size and click save. Didn't give a decent name for it, so let's say bus location at route number 1. Opacity again, let's go with 55. Likewise, you would create layers for other routes and bus locations. With that, we have covered all the scenarios that we wanted. Let's do a recap. So we saw pulling data from nextbus.com in the form of XML, transform it into JSON, and then push it to Elasticsearch. We also saw how to represent this information on maps. With that, I hope you find this video useful. Thank you.